All right, so we are going to keep graphing. We're going to be graphing a lot this year. And with graphs, we always start talking about domain and range. The domain are all the values that you input into a function or into an equation. Input values, that's the domain, input. Usually, we use x to input those values. Usually, it does not have to be x. Usually, we use x. And on the graph, it would be the left to right. Numbers that would make it not in a domain, reasons why you would have numbers not in a domain, would be, let's say you have a square root and a variable underneath the square root. Do you guys remember something that you cannot have under a square root? Negatives, right, that would make it an imaginary. So if we had an x under a square root, we would have some values that were not in the domain. Or if we had, maybe we had a fraction, like 1 over x plus 4. Maybe we had an example where we have a fraction. If I have a number in x that creates the denominator to be 0, can I have a number over 0? Am I allowed to have an NO, a number over 0? No, I can't. See, it even says no. That would be undefined. So that would be another reason that, like in this case, it would be -4, would not be part of the domain because we can't have -4 in that spot. Now the range is affected by the domain. The range is the outputs. So you have to put something in first to get something out. You aren't getting anything out of it if you don't put it in. So output comes second. Usually we do like a y, or maybe we do like an f of x if it's function notation. This is the up-down on the graph. And restrictions on the range are just really going to depend on restrictions on the domain. I can't just look at it and be like, this is what always causes restrictions. It's really depending on the domain. So if we have a linear function, if we're talking about functions, then we put it in function notation, f of x equals mx plus b. If we have a linear function, we will not put it in standard form. We won't put it in point slope form, because to be a function, it has to be like y equals. So f of x equals, it will be in the mx plus b form. When we have lines, our domain is always all real numbers. That's the symbol. I meant to write the word first. All real numbers. If you need to answer a question on your assignment that asks for the domain, you can either write all real numbers, and yes, you can put spaces in between the words all real numbers, okay? Or you can use the symbol. However, Canvas does not have that symbol. So if you want the shortcut, if you want to use the symbol, then just use a capital R. That's not the real symbol. The real symbol has the fancy 2-line thing. But I'll just set up the Canvas answer key that will accept either the words all real numbers or a capital R. That means all real numbers. Range for lines is also all real numbers because they go forever up and down. The intercepts, we've got a y-intercept at 0b. And the x-intercept really depends on what the equation is like, but I'll just put like A0 for the x-intercept. I could label these x-intercept, y-intercept. Just remember for intercepts, the other variable is 0. To have the y-intercept, we have to have a y. It's just x is gone. X is 0. The behavior of the graph, lines, go either constantly increasing or constantly decreasing. So the behavior could be going from down to up or from up to down as you read left to right. There's a couple special types of linear equations. The constant f of x equals c, where c is just a number. You can see a graph of a constant right over there. That would be like y equals 5, or f of x equals 5. And then the identity function is f of x equals x. Identity means like it's equal to itself. So x and y are the same thing. And there's the graph of that as well. Y equals x, f of x equals x. They're the same thing. One important thing about function notation is I cannot write this equation in function notation. I'll make it even easier. I'll say this is 2. Does anybody know the equation of this line? Does anybody know the equation of this line? Ava. Right, this is the equation x equals 2. Why can't I write that in function notation, f of x equals... Why can't I write that in function notation? Eva. Because it's not a function. That's why. You can't write something that's not a function in function notation. So we won't have any x equals if we're talking about functions. It fails the vertical line test. Or like Ava said, f of x is y equals, and this one doesn't have a y in it. All right, so we won't have any of those in function notation. If you were asked to write a linear function, you will notice that it will give you f of, this says f of 1 equals 3, f of 4 equals 0. This is an input and an output. If I put 4 in, I get out 0. If I put 1 in, I get out 3. What they're doing is telling you 2 ordered pairs that fit for this function. The first ordered pair, if I input 1, that's my x, I get out 3. The second ordered pair, if I input 4, I get out 0. In order to find this equation, we need y equals mx plus b. What information do I need? Courtney, what information do I need if I want to put it in y equals mx plus b? I need the slope, so we find the slope. 0 minus 3 over 4 minus 1, negative 3 over 3, negative 1. Got my slope. What other information do I need? It needs to be in y equals mx plus b. What information do I need? Kevin, what do I need? To put it in y equals mx plus b. I couldn't understand you. I just couldn't understand what you said. I need a point? Oh, I got a couple points. Oh, I could put it into point slope? Right, because I need it to go into y equals mx plus b, so I could put it into point slope to get there. That sounds good. Do you care which order of pair I use? Does anybody care which order of pair I use? I care. Which one? First one? I prefer the second one, but it really doesn't matter. I prefer the second one because there's a 0. That means I have less work. But that's what I'm going to use. Y minus y1 equals m times x minus x1. Point slope form. Y minus 0 equals negative 1 times x minus 4. So y equals distribute negative x plus 4. So is that in slope-intercept form? Is that in mx plus b form? Okay. This is not the answer. This is where people don't do their work and forget, or don't study and forget. So when I'm talking about write the linear function f, that is telling you the answer has to be f of x equals negative x plus 4. So we're not going to write y equals, we're going to write f of x equals because they literally told you to name it function f. So that's just one tiny little detail we got to look out for. All right. It also says to graph it. So 1, 3, 4, 0. I'm not going to take a ton of time to graph it because we already graphed a bunch today, and I'd rather get further. But just make sure that your slope fits those points as well. So this is called library of functions. We're going to go through a bunch of functions that you studied last year. And then what this is going to lead up to is transformations of functions, which you studied last year. So absolute value looks like f of x equals absolute value of x. These are parent functions. These are before any transformations. Absolute value looks like a v. I always use the same parent points. I use things that I can easily plug into absolute value of x. So -2, -1, 0, 1, 2 work very nicely plugging in. When I plug those in, all the answers are positive. And when I graph it, and I know I'm graphing fast, but this is a review from last year, and you can always go watch the video. If I'm going too fast on the graphing part, I will slow down on the new stuff. It looks like a V. So the domain would be, what numbers am I allowed to input? What numbers am I allowed to take the absolute value of? Or you can look at the picture. How far to the left and how far to the right does it go? Everything. It goes all the way to the left, all the way to the right. This is all real numbers. I am not going to keep writing out all real numbers. I'm going to put the R. Okay. Range. Range is, after I plug in numbers, the absolute value makes them all positive. So I'm not getting everything back. You look at the graph. How far down does the graph go? All the way? Is there an arrow pointing down? No. It goes down to 0. And then it goes all the way up. So what we're going to do is we're going to say that the y values are greater than or equal to 0. They're starting at 0 and they're going up from there. Greater than or equal to 0. Intercepts, normally we've got like a 0, 0 for the vertex, for VE, that's a V, ER, TX. But we'll talk more about stuff like that with transformations. I'm not going to spend too much time on intercepts and behavior. That's not the most important part of what we're doing today. Behavior would be either both ends are up or both ends are down. Those are our options for absolute value. Next is quadratic. Quadratic, I know you spent a lot of time on quadratic in Algebra 2. That's like half of Algebra 2 is quadratics. I personally like having 2 more boxes, so I just added them on. And I like to do -3 to +3 for quadratic. Oops, that's not it. For the y value, we just take the x value and square it. And when you square numbers, you always get positive numbers. When you square it, you always get a positive. And hopefully you graphed so many of these that you don't even really need to think. Maybe we need to review it before you're there, but I don't even have to think about, like, look at the table and plot those points. I just know, like, you go out 1, up 1, out 2, up 4, out 3, up 9. Like, I just know that because I've graphed them so many times. All right, domain. So this parabola is getting wider and wider. Is there a number that I can't put into x squared? Or if you look at the graph, does it ever stop going to the sides? No. So it's all real numbers. The range is down to up. But because we have that squared, that does affect the range. We can't get negative numbers out of that. So our range for this one is going to be all the way down to 0, all the way up. So y is greater than or equal to 0. The range is up and down. Intercepts, we've got a vertex at 0, 0. There will be more intercepts when we start transforming it, translating it. And behavior of the graph, they're either the two ends are up or the two ends are down. Cubic function. Let's see who remembers cubic. So into the table, I'm going to put numbers that I can cube and fit on the graph. So really, it's only -2, -1, 0, 1, 2. When I cube those, I get -8, -1, 0, 1, 8. So that's what the cubic parent function looks like. There is no limitation on what I can put into the equation, what I can input and put to the third power. There's no limitation. If I look at my graph, it will keep going to the left and to the right forever. So domain is all real numbers. And then cube does not affect negatives or positives either. So it goes all the way up and all the way down. So all real numbers for range as well. That will be the same for every cubic function. All reals for both. Intercepts, it's not called a vertex, it's called a point of inflection. That point of inflection is that currently it's at 0, 0. That will move around when we have transformations. It's that point where the graph goes from concave down to concave up, where it changes how the graph looks. And then the behavior of the graph is a lot like the line, where we can have it either goes all the way up in one direction or it goes all the way down in that direction that you read. The two ends are at different infinities. All right, square root. Anybody remember what square root looks like? Anybody remember? Well, the graph looks like this. Can you tell? Oh, you didn't see me dance earlier. Parabola, absolute value, cubic, square root. Okay. Don't worry, we'll do it someday in here soon. Square root. So as I'm picking my points for x and finding my y's over here, I want to be smart about this. I want to put things that I can put in square root. What can't I square root? Negatives. So I'm not going to pick any negative numbers. Also, I'm going to pick numbers to put in that I like to square root because they're easy. So I'm going to pick 0, 1, 4, 9, 16. I'm going to pick perfect squares. You can pick whatever x's you want. Those are going to make your life easier. When I square root each of those numbers, I get 0, 1, 2, 3, 4. I graph it. My 16 doesn't even fit on the graph, so I don't even need that one. That was kind of ugly. I'm sorry. I got to redo this. It's ugly. Still kind of ugly. Okay. So the domain for the square root. Does it go all the way to the left and the right? No. We have a domain restriction, meaning you can't have negatives under that radical. So the domain is going to be just 0 and above for x's. So x is greater than or equal to 0. Greater than or equal to 0. And then the range, we have a limitation on that also because of the domain. So y is greater than or equal to 0 as well. Intercepts, it just really depends on the transformation. So this one would be at 0, 0. The behavior of the graph, it really depends on the transformations, but it's really only going to go in one direction. So I'm not going to really fill anything out about that. The last parent function we're going to look at today is called a reciprocal function. Reciprocal function, whatever x's I pick, I have to flip them over for the y's. So I'm going to pick x's that I can flip over. I can flip over -2, -1. I'm going to put -1/2 in there. I'll put 0, 1/2, 1, and 2. So I had to add a couple extra boxes. You'll see why. So what happens if I flip over -2? If I do 1 over -2? What do I get? Close. It'll be 1 over -2. To be -1/2. Did you say -1/2? Okay. If I flip over -1, 1 over -1 is still -1. What happens if I flip -1/2? I get -2. And that's why I gave you that one, because I knew when I flipped it, it would be a nice number to graph. And 1/2 isn't that bad to graph. What happens when I take 0 over 1 and I flip it? Say it louder, I heard somebody. It's undefined. This can't happen. So something special happens because of that. I'll get there in a second. And then I flip 1/2, I get 2. I flip 1, I get 1. I flip 2, and I get 1/2. So I'm going to plot these. And we will have, oh, and you know what? As I'm plotting these, if you were in CP Algebra 2 last year, I can't guarantee you did exactly what I did, but the majority of us teachers we skipped these because of quarantine. It was in Chapter 7 when we first went on quarantine. We skipped graphing these. So this potentially could be the first time some of you are seeing this, okay? So where we have an undefined, if x is undefined, that means x cannot equal 0. Where x is undefined, or I'm sorry, when you plug in 0 and we get an undefined answer, that means x cannot equal 0. And for those of you that were in honors before, this becomes an asymptote. And again, it depends on what teacher you had, but we should have talked about asymptotes in regular Algebra 2, but I know we just didn't do this kind. Because asymptotes are in logarithmic and exponential too. So x equals 0 is an asymptote. Where x equals 0, that's a vertical line. I'm just going to put like a dashed asymptote, a line that the graph is getting closer and closer to, but it's kind of like a border where it's not going to pass it. It's kind of a break in the graph. Because x can't be 0, there's no way that we can have 0 in for y and solve for x. There's absolutely no x value that can make y 0. The only thing that could possibly do it would be 0, but x can't be 0. So y can also not equal 0, which is another asymptote. So at y equals 0, there's an asymptote. So the axes become asymptotes. I can plug in more points if I'm not sure what the graph looks like, but I'll tell you it becomes a hyperbola, which the graph just gets closer and closer to the axes, but it doesn't pass through it. So you do your best job to make it look like that. That side was kind of bad. So it kind of like these two branches that don't actually connect to each other. The domain for this, we're talking about x's, it's everything except one number. The domain, x cannot equal 0. The range, it goes all the way up and down except one number. Y cannot equal 0, right? So that would be what we write for our range. There aren't any intercepts. We're not going to worry about the behavior of the graph. So what's going to happen, I've gone through these. I will continue this video. I'm going to pause it because class is almost over. But what I'm going to do is I'm going to continue this video, and I won't stop until I have all of these finished. so that you can go back and watch the examples. But we're going to use a transformation table to take x squared, that parabola. And does anybody remember, if we have a plus 2 on the outside, what that does to the parabola? It makes it go up 2, right. So once you know where that original parabola is, you can just go doot, doot, move it up 2, and you're done graphing that one. So we're just going to do transformations on this last page. Your assignment is, not everybody leaves in 2 minutes. Your assignment are the 2 worksheets. The first one, you guys had already started. It says on this day, there's 2 assignments. There's an assignment, and then later there's another assignment. The only thing that I don't currently have is where it says enter assignment here, and it says coming soon. That will be up soon. It just isn't up yet. The first one is.
What are these due by?
They are due, and the assignment will say when it's due, but since the other one's not up yet, it is due Thursday evening, which is after we have 2 XHs and class. So if you do have questions, and you don't email me, and you don't come see me in XH, you can still ask me in class. But keep in mind, we're finishing 1-5 and we're studying for a quiz. So you could definitely have time to ask me questions in class, next class, okay? All right, so let me turn off this video. Nope, pause the video because I'm okay, so example 2 is using a transformation table. Write the domain and range of the function. So we look over here and we see that the function is x squared. That is the parent function. So using our notes from above, where we got our quadratic parent function, we have ordered pairs, -3, -2, -1, 0, 1, 2, 3. And the y values are 9, 4, 1, 0, 1, 4, 9. You do not necessarily need to plot these points of the original function. I'm just putting them there for reference. What we need to do is we need to remember from last year, what did a plus 2 do to the equation? Well, because the plus 2 is not being squared, it is a vertical transformation. Because it's not part of the squared, which the function is squared. It's not part of that, it's going to be vertical transformation, and since it's plus 2, that means we're going to translate up 2 units. Over here on my table, we can show that since it's a vertical transformation, I'm going to put it on the side of the vertical numbers, on that y side. So this is going to be a different y value. I'm just going to add 2 to every single y value here. And I won't use the blue ones anymore. So now I have new ordered pairs. So you can either look at these ordered pairs, or we can just go to the graph, and this just transforms the entire parabola, the entire quadratic equation, up 2 units from each ordered pair. So right now that's what I'm doing, is I'm taking each ordered pair and moving it up 2 units. These 2 are off the graph, but that's okay. Whoa, sorry, there was a cord in my way. I couldn't do it very good. Okay. Now the domain for this one, all reals for the domain for parabolas. And then the range, because we did move it up 2, now the bottom of this equation is where y is 2. So the range is going to be that y is greater than or equal to 2. The next question we look at, and it is originally a cubic. So x cubed would be the parent function. So I'm going to start with my x cubed, excuse me, my x cubed points. So we'll have -2, -1, 0, 1, 2, and these came from above in our notes. -8, -1, 0, 1, 8. And we're going to look at the transformations. What is being done to this x cubed? Nothing else is being cubed. Because nothing else is being cubed, everything done is going to be vertical. Everything outside of the cubed is going to be vertical. So everything that we do is going to go to the y's. So in our transformation table, we have a negative in front of the cubed, so that's a multiply by -1. We also have an adding 1. I know it looks like it's subtracting, but the minus sign goes to the cubed. In front of the 1 is an actual positive, so adding 1. Now, between these two, it does matter which order that you do them in. So I'll just make them in different colors so that we can follow along here. The order does matter, and we just use order of operations. So out of multiplying by -1 or adding 1, multiplying is going to come first. So the next thing that I'm going to do is I'm going to multiply all my y's by -1. So I'll have 8, 1, 0, -1, -8. So we reflected this. We changed all the signs. After that, now I'm going to add 1 to all the new values of y. So I will have 9, 2, 1, 0, -7. We will not use the previous y's. We only use the very last one with those x's. I didn't put the original function in. Let me graph that really fast so you can compare the parent function with the new function. I'm going to dash that a little bit. So there's that original function in there. So now the new one is reflected, and it is up 1 more. So we've got -2, 9, -1, 2, 0, 1, 1, 0, and then 2, -7. So you can see that this graph is reflected, and from that point of inflection in the middle, it is moved up 1 unit. Now, for domain and range, cubics are always the same. Domain and range are both all real numbers every single time. There's nothing, there's no restrictions on that. All right, square root of x plus 4. So I'm going to start with my square root parent function. The square root of x, that is, I'm using 0, 1, 4, 9, 16. Doesn't even fit on there, so I'm not going to bother. And then 0, 1, 2, 3. Now, when we talk about using transformations, the square root is the parent function, and this plus 4 is under the square root. It is part of that function. So anything that's part of the function, anything that's under the square root, will be horizontal. And for a horizontal change, we always use the opposite operation. So for this one, because there's a plus 4 in my table, and I didn't put the words opposite operation in a very good place. Let me move that really fast. Okay, in my table, I'm going to do this on the x side because it's horizontal, and it is, since it is a plus 4, I'm actually going to do the opposite. I'm going to subtract 4. So since I replaced the x's, I can get rid of those x's. I didn't graph the parent function. Let me do that real fast so we can compare. You don't have to graph the parent function. I'm just having it here for notes so you can compare. So this one is -4, 0, -3, 1, 0, 2, 5, 3. So you can see that this one is just moved over to the left by 4 units. translated 4 units to the left. Our domain, so we're talking about the x's. We're talking about left to right. So if I look at the picture, it does not go all the way to the left. It goes all the way to -4. And then from there, it moves all the way to the right. So what we'll say for our domain is that x is greater than or equal to -4. And our range is down and up. So over here, I'm going to look at the lowest that this graph goes. Here, I'll put it in a different color. The lowest this graph goes is right here, and that's where y is 0. And then it goes up from there. So the range is going to be y is greater than or equal to 0. You will notice that the transformations very often have to do with the domain and the range, the numbers in the domain and the range. Because I did -4 to the x's, that affected the domain. Because I didn't do anything to the y's, nothing changed about the y's, the range. All right, and then we've got p of x equals absolute value x minus 2 minus 3. So I'll start with my absolute value parent function points. Absolute value of x, that's -2, -1, 0, 1, 2. And when I put that in, we get positive, 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 positive. Now, the -2 is part of the absolute value. That is inside the function. And anything that is inside the function is going to be horizontal. That affects the input. Inside is affecting the input, the x values, the horizontal. So, and anything horizontal, we do opposite operation. In my table, to the x values, the horizontal values, because this says subtract 2, I'm going to add 2. I'm doing the opposite operation. 0, 1, 2, 3, 4. Now, the -3 is outside of the function. And anything outside is going to be an output, a y value, a vertical value. So, and those don't change the signs, so we just use subtract 3. Now, I don't even need any of the x's or the y's. I, of course, forgot to graph my parent function. Again, you don't have to do that. I'm just trying to help you, see this graph and how it transforms. So let's see, we've got 0, -1, 1, -2, 2, -3, 3, -2, and 4, -1. Oops. Try to make that line not so sloppy. I guess I could be using the straight line. That would be smarter. Okay, so I've got my graph, and we can see here that, from the original function, this graph moved 2, like if I'm looking at the vertex of the graph, it moved 2 to the right and down 3. So we translated 2 to the right and down 3, and that's all that happened to that function. So the domain first is all the x's, so from left to right, this is all real numbers. The range, we're talking about down to up, so the lowest point that this absolute value goes is -3. So y is greater than or equal to -3. Okay, if you have questions about transformations, if that is stressing you out, maybe you don't remember a lot about transformations from last year, you can always just make a table and plug in any values you want and plug them all into the equation and get, numbers here and just graph those. You don't have to do the transformation table. However, what happens when people do it that way is sometimes you end up with an absolute value that looks like this. And you don't know where the V part comes in. Like, is it over here? Is it over here? We don't know. So that's why we do transformations instead. Make sure that you are aware that you have 2 assignments. The first assignment over 1.2 linear equation standard form. The second assignment, just moving around some parent functions, and entering your assignment will be coming soon for that one. It will be uploaded soon. And I will also have your YouTube notes uploaded so you can watch the videos for anything that you've missed. Let me know if you have any questions.